This is the Alphabet and Grammar of Geometry Preview Video 1.1, Part 3. Take a moment and close your eyes. Inhale through your nose. Hold your breath. Exhale, count 5. Eyes closed for a few more seconds. Take another deep breath and open your eyes. Alrighty, students. This is now the preview video 1.1 part 3 algebra review. Make sure you get a date, time, location, parental sign off. We are going to be working with radicals, probably the most important skill, algebra review skill for geometry. We're going to add, subtract, multiply, and divide radicals over the next few minutes. Step 1, really key thought, is the fact that radicals follow the same rules as variables. Radicals follow the same rules as variables. So take a look here. And if we were to simplify this expression, we would first collect like terms. So this would end up being negative 6z. See what I'm doing? So I'm going to cross things out as I collect them. And that's 3x minus 2x, so that's minus 1x. And I'm done with that. I'm going to cross it out. And 8y minus 5y, and that's going to be positive. This was positive as well. And there we go. That's going to be positive 3y. And then that as far as you can go. Okay, it's very important you understand it. That's as far as you can go. There's nothing else you can solve for. So, taking a look here, the radicals, if you look carefully, it's actually color-coded, follow the same rules as the variables. So do you see that? Root 2? So we're going to add them as if it was the z's. So that's going to end up being negative 6 root 2. Notice I did not change the root 2 there, just like I didn't do anything with the z's there. Okay, the x's are now root 5. So it's positive 3 minus 2, so that's positive 1. Root 5. You can just put root 5 there. And then here you have 8 minus 3. That's going to be positive 3 root 3. And we are done. Radicals follow the same rules as variables. Okay, knowing that simple concept, another thing you have to be able to do is our previous skill, which is simplify. So before you add and subtract, you must simplify. The reason why we didn't do that here is these radicals, I kept them very simple. They're already in their most simplified form. But these ones down here are not. Let me show you what I mean by that. So taking a look at the first one, simplified means you can factor it still, which the 20 you can. And you can factor the 18. The 5, that's as far as you can go. All right, once you do that, now we're going to simplify. We have a pair of 2's, so the 2's are going to come out. One pair of 3's come out, and there's a minus sign and a 3 on the outside, so that's 3 times 3, so that's minus 9 root 2. There's nothing that comes out, so this just stays 3 root 5 over here. The 3's come out, and it's 1 3 times the 2. It's positive, so it's plus 6. And then we have root 5. Now we collect like terms. Root 5, root 5, root 5. Negative 2 minus 3 is negative 5, root 5, plus 6. That ends up being 1 root 5. Negative 2 minus 3 plus 6. Then minus 9 root 2, and you are done. This is the same answer. If I went like this, negative 9 root 2 plus simply root 5, that's, you can switch watch those. Just like 2 plus 3 is the same as 3 plus 2. Okay, knowing that, you need to simplify before you add and divide. This is the you try. You're going to pause the video, do this on your own, and then restart. Alrighty, let's check out what you did here. You should have factored this, and it ends up being negative 2 root 5. That's as far as you can go. This is negative 9 root 2, 3 root 2. And then here we have 4 root 5. Collect like terms. Your final answer should be negative 2 root 5 minus 6 root 2. Okay, that's adding and subtracting radicals. Now we're going to multiply. And we have 3 steps to multiplying radicals. Outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. These terms, outies and innies, obviously this is kind of a slang for something. I'll explain in just a moment. And simplify. Let me show you what I mean by this. Outies, you multiply the outer coefficients first. And then you multiply the inner coefficients. But the key to multiplying is not multiplying, it's factoring. So watch what I do. I'm just going to leave it at 3 and 6. I factor both. Okay, see what I did there? And then you just pull out the dates, which is a pair of 3s. There's 1. And I'm just going to kind of grab it and bring it around. Okay. Do not be grabbing calculators for single-digit multiplication, folks. That's a no-no. Just don't do it, okay? Use your brain. Alrighty, that's 3, that's 6. So on the outside, it's going to be 63 root, and then we have here 2. Outies, innies, simplify. I like you to follow those 3 steps right here. Pause the video. All right, students, did you actually pause the video and now you're correcting your work, or are you copying? If you're copying right now, please stop. Get in the habit of always doing your own work. Then you're supposed to get out a red pen as directed. I should make that red. Anyways, red pen, and then you correct your work. It's okay if you're wrong, folks. If you're wrong, you just write yourself a note. What are you going to do next time? And remember, I'll ask yourself that. If you're right, some sort of big, I'm such a brilliant young man, young woman, and some sort of smiley. Okay, so right here, you should have ended up with 70 root 3. 70 root 3. So we've added, subtracted, multiply, and the last one is dividing. Outies, innies, simplify. It's the same 3 steps. Although there's a little bit more work here when you're dealing with division. Outies, innies, simplify. Outies, innies, simplify. Ready? We're going to do this one together. Step number 1, we are going to reduce and factor out our outies, our outside coefficients, and our innies. All right, so the 4 and the 24 reduces. 4 goes into 24, 6. Down below there's a 1. I'm just going to leave that 1 there for simplicity. Okay, 3 goes into 15 and 3 goes into 21. So that's where that came from. Outies, innies. Great. How do you simplify a radical in division? One of the primary rules in working with radicals is you do not leave a radical in the denominator. I'll call that a radical in the basement. So in order to simplify that, we're going to multiply the top and the bottom by that radical that we're trying to get out of the denominator. I'll show you why in just a moment. We had a root 7 and a root 7. Okay. Root 7 times root 7 technically is root 49. But root 49 is a perfect number. So it just becomes 7. That's a key skill right there. Any radical times itself is just the number on the inside. So what we have up here is we have 6/35 over 7. Now as the final step, you check, can this be simplified anymore? The answer is no. And can this be simplified any more than 35? The answer is no, because both 5 and 7 are prime. Outies, innies, simplify. Alrighty, folks. You're going to follow those 3 steps here on your own. Pause the video, work in pencil, then restart. Pause the video. Alrighty, so hopefully you got this far as your outies, innies, and when you simplify top and bottom by root 3. So what you're going to end up with, now careful, there was a little bit of a trick here. Let's see if you caught this trick. If you didn't, I totally get that. So we have root 24 over, that becomes 3/21. Now, if you got this far, I totally understand why you think you were done, but you're not. Because root 24 can be simplified yet again. Do you see that you could pull out a pair of 2's? So your final answer here is 2 on the outside, root 6 over 21. And you check the outer, that doesn't reduce. That means this should be your final answer. So if you did not get that, you should be writing yourself a note. What are you going to remember next time? Alrighty, last step here, last simple step. There's a very important pattern I need you to be able to spot, and this literally takes like 30 seconds, so it's very simple. Root 2 times root 2 technically is root 4. However, that's perfect. So root 2 times root 2 becomes 2. Root 7 times root 7 technically is root 49, which just becomes 7. You starting to see a pattern here? Root 5 squared technically is root 5 times root 5, which is going to just be square root of 25, which is 5. Root 17 squared. Now, some of you are like, yikes, I need to grab a calculator for that. No, you don't. Do you notice the pattern here? Root 2 times root 2 is 2. Root 7 times root 7 is 7. Root 5 times root 5 is 5. Root 17 times root 17 is, looky there, 17. Look how easy this is. Now ready? Look at this pattern. Root 2 times root 2 is 2. Therefore, 3 times 2 is 6. So 3 root 2 times root 2 is 6. Last one. 6 root 5 times what number is 30? Ask yourself this. What would give you a 5? Because 6 times 5 is 30. Another root 5. Because root 5 times root 5 gives you the 5. 6 times 5 is 30. Do you see that pattern? All right. I'd like you to pause the video, zoom through this page. It should literally take you about 45 seconds. And then grab your red pen. Pause the video. Okay, you should have switched to your red pen. There's your first row, 5, 6, and 15. The second row in the gray boxes should be 3 and 21. That's 30, and the missing there is root 5. Very important to, again, take 1 minute and try to explain, especially maybe this last page, to a family member, a friend, a stuffy, a pet on the bed, or to yourself. Go.